All right, guys, I hope the first Learn from Home week was a good one. And I want to take some time to kind of recap what should we have learned in week 2. It was week 1 for you, but it's week 2 in terms of school as a whole. So let's start with 1.1. In 1.1, you should have talked about the structure of an atom. So atoms have protons, neutrons, and electrons. A proton is in the nucleus. It has a positive charge, and it is a heavy particle, so it has mass. So it can affect the mass of our atoms if I change it. We have neutrons. Those are in the nucleus. Those have no charge. They're neutral, and they also have mass. And then we have electrons. They orbit around the nucleus. They have a negative charge, and they're very light, so changing them does not affect the mass of the atom. So how does changing these affect the atom? This was part of one of our questions, the F, G, and H on the PhET lab. If I gain or lose protons, not only does it change the element because the number of protons determines the element, it can change the charge because you're affecting that positive charge in the atom, and it can also affect the mass because protons are massive, and so they can affect that mass. If I gain or lose neutrons, the only thing that changes is the atomic mass. And then if I gain or lose electrons, the only thing that changes is the charge of the atom. Okay, so let's talk about reading the periodic table. If we look under resources or the classwork tab on Classroom, there's a whole topic on just periodic table and other reference tables. So I posted the periodic table that I use there, and it has this little thing, this little key in the top. So it gives you a key. It tells you this is what one of your squares looks like, or one of your boxes in the periodic table. The top number is the atomic number. That atomic number automatically tells you the number of protons. So gold has 79 protons. Every atom of gold has 79. If it doesn't have 79, then it's not gold, it's something else. Then we have the element symbol, the element name, and then the average atomic mass on the bottom. So the atomic mass, we are going to round those numbers. So if I was reading this from the periodic table, I wouldn't put that gold has 196.97 as its atomic mass. I would just say gold has an atomic mass of 197. Round it up to 197. If they need to round down, round down. If it needs to round up, but let's round them to a whole number. Another easy way to figure it out, if you already have the atom in front of you, is the atomic mass is what I get when I add up the protons and neutrons. So here, if I wanted to figure out, how many neutrons gold has, let's see, I would write it like this. So the atomic mass, let me change that color. So the atomic mass equals protons plus neutrons. So the atomic mass for gold is 197. That is going to equal the number of protons, which we said was 79, plus the number of neutrons. So how would I solve this equation? What plus 79 gives me 197? Well, if I just subtract those two numbers, I get that the average gold atom should have 118 neutrons. That's because 79 plus 118 gives me 197. Unless we're told otherwise, if I'm reading it from the periodic table, the number of protons and electrons are going to be the same. All our atoms are going to be neutral unless it's specified otherwise. And we'll talk about ions in a second. So, another example, vanadium, atomic number 23, atomic mass of 51 because I round up. So what can I get from those two numbers? Well, I can get the protons are 23 because the atomic number is the number of protons. If protons and electrons are the same, then electrons are also 23. And then what plus 23 equals 51 to get the number of neutrons? Well, that would be 28. Again, if I add protons and neutrons together, that gives me the atomic mass. So that this formula is probably vital to remember and write down somewhere. All right, that's pretty much it for atomic structure. 1.2, ions, isotopes, and notations. So what is an ion? An ion is an atom with an imbalance of charge. I should put that there, an imbalance of charge. And that means it has different numbers of electrons and protons. If there are more electrons than protons, the atom is an anion, and all that means is it's a negative ion. So overall, its charge is negative because it has more negative than positive. If there are more protons than electrons, so if there's more positive charge than negative charge, then that atom is called a cation, and it is overall a positive ion.
Good morning, everybody. I hope you have a wonderful...
Sorry about that. Let me say that again. If there are more protons than electrons, more positive than negative, the atom is an cation, and so it overall has a positive charge. All right. Isotopes. Isotopes are the reason that the atomic masses are decimals on the periodic table. That's because in real life, atoms of carbon, nitrogen, whatever, they could all have different masses because I can have the same element and two different atoms have different numbers of neutrons. Because remember from the PhET lab, when I change the number of neutrons, that doesn't change the element, it just changes the mass. So isotopes are the same element, but different atoms with different masses. So how do we notate this? Well, there's two ways. There's the nuclear notation, which up here, you've got your periodic table notation. Nuclear notation flips that, puts the mass on top, the atomic number on the bottom. I kind of like this notation because if I'm trying to find the number of neutrons is the mass number minus the atomic number. So it kind of sets it up for you. Again, sorry about that. The mass number minus the atomic number gives you the number of neutrons. So if I need to subtract, I just subtract from top to bottom like you would draw it, like you would write the subtraction anyway. So I'd see that this particular isotope of carbon, if I want to find the number of neutrons, it'd be 12 minus 6, so I would have 6 neutrons. Hyphen notation is a little bit easier because you just write the name of the element with a hyphen and then the mass number. So this number represents the atomic mass. What that means, if you see something like carbon 12, carbon 13, carbon 14, those are all carbon. They all have 6 protons because the atomic number is 6. They're all isotopes of carbon. That means they have different numbers of neutrons. The key here is you can differ the number of neutrons, but as soon as you change the number of protons, if I change the number of protons of carbon from 6 to 7, all of a sudden that carbon isn't carbon anymore. That carbon turns into nitrogen because nitrogen has an atomic number of 7. So we can change neutrons, we can change the atomic mass, we cannot change our atomic number because that changes the element. I hope this was helpful. Again, keep commenting if you have questions. I've been loving all the comments, and I'll do my best to try to keep up with the work that's being turned in. Have a good day.